Hello dear students, welcome to Pen and Paper Chemistry. So are you ready with your pen and paper as we progress towards learning various topics in chemistry, that is organic, inorganic and physical. In today's lesson I've tried to make the numericals easy and fun to learn, but you will derive maximum benefit out of this lesson only and only when you have your pen and paper ready to practice the numericals that we are going to take up in today's lesson. So let's get started. Our first numerical for the day is based on mass percent, molarity and molality. Now these are the terms that we spoke about in the last video and we cleared a lot of doubts also on that. I hope the formulas are in place. Now once the formulas are in place, I'm going to teach you a very easy way of doing numerical, any numerical. So you need not stick to, you need not worry about numericals in any other chapter also once you follow this technique. What is the technique? I have listed some steps over there. No, please don't start memorizing those steps. You need to understand, and those steps anyway we are going to follow today while solving the numericals. What do you do in the first step is, as I mentioned, you need the formula in place, right? And you also need to know what do you have to calculate in the question. So as I showed you the previous question, in this particular question I have to find out the mass percent, the molarity and the molality. So make sure that you write down whatever is needed or required to be calculated. So for example, molarity, molality, mass percent, just jot it down. Second is make sure that you put down the formula for each one of them separately on the right hand side of your paper. So that is where the formula goes. Third step is, yes, a very important step, that is what has been provided to us in the question. So what you do is you read the question properly and maybe you can start highlighting whatever is the information or underlining, right? You don't need fancy sketch pens and stuff like that for it. It is just for indicating it to you that I'm using different colors, right? And if you see over here, I've written in capital tabulated. That means put it in the form of a table. How am I going to do it? I'll show it to you. This is a technique which I devised today only and I have loved this method. Step 4, make sure that you check the units of the data which has been provided to you and you convert it wherever necessary. Step 5 is simple. You had written the formulas at the first step, at the second step itself. What do you have to do is you just have to substitute in the formula, calculate and make sure that you put the correct unit for your answer. Don't forget that. Okay, so now let us apply our steps to this question where it says 400 ml of an aqueous solution of sodium carbonate has a density. So there's density provided to us. If the given solution contains 24 grams of sodium carbonate, so which is the solute, dissolved in it, calculate mass percent, molarity and molality of the solution. So first things first, what do we have to find out is, first is mass percentage. That means W by W of the solute about the solution times 100. That's the first thing I have to find out. Second is I have to find out molarity. So what I'm doing is side by side I'm writing the formulas as well, so I know what do I need. The third is molality, right? Molality is W upon M into weight of solvent. When you have it in grams, you convert it into kg times 1000. So I have 3 things in place. Next step is to go through the question and see what all data is provided to us. So we've got 400 ml of an aqueous solution. See, if you notice over here, there are too many things. You have the solution, you need the solvent, so what I'll do is I'll actually take you to the next step where I have said that you tabulate it. Yes, how do we tabulate it? So I'm going to draw a table over here. What am I going to do is I need solute, solvent and solution. I need weight of solute, I need the weight of solvent, I need the molar mass, I need the volume. So let me roughly draw this figure and make a note over here. So I have the solute in this column, I have the solvent in this column. My solute is sodium carbonate, Na2CO3. I hope you know how to write the formulas. Solvent is of course water, because we have been given that it's an aqueous solution, and of course the last column is solution. Next thing is the weight of the solute. So that is weight, and because I know from my earlier knowledge that weight we have to take in grams, what we are going to do is we are going to put the weight in gram over here, right? Then we need the molar mass. Now this molar mass is given in gram per mole. So I'm going to put the unit over here. Then I am going to talk about volume. Is there anything else that we need? Let's see. Okay, so it says, yes, there is one more. There's density provided to us, right? And that density is of the solution. So let's make one more column over here, density, right? Of course, we won't have the density of the solute and the solvent, but there's no harm in doing that. Now let's start with whatever is given to us. We've been given that we've got 400 ml of an aqueous solution. So I substitute over here, solution is 400 ml. So we know that we have to convert it into liters. Why do we have to convert it into liters? Because for molarity we need it in liters. So this would be divided by 1000 gives me 0.4 liters. That's one thing sorted out. See, I'm changing the units as well. The solution has a density of 1.6 gram per milliliter. So density is 1.6 gram per milliliter. Oh, that's interesting, right? So I've got the volume of this solution, I've got the density of this solution. That means if need be, I can easily calculate the mass of the solution. How do we calculate mass? That is volume into density. This density can be written as D. It can also be denoted by the symbol rho. Both are correct. So I will have over here, because my volume is in milliliters and density is in gram per milliliter. So we will have 400 times 1.6 and we get the weight of the solution in grams. Can you just solve it for me and give me the answer? Okay, so you got it as 640 grams, right? So on the right track, yes. Let's see what else is given to us in the question. If the given solution contains 24 grams of sodium carbonate, that means this has been given to me as 24 grams. Just to be sure, what I'm going to do is I'm going to put the unit as well. Oh, interesting. You see, in this column, I've got the weight of the solute, I've got the weight of the solution. So if required, I can also determine the weight of the solvent. That's if we need. And do we need the weight of the solvent? Yes, of course. For molality, we'll need the weight of the solvent. So let's sort this out as well. So we will have over here 640 take away 24. Please give me the answer. Okay, 616 grams. Is that right? Okay, we are on the right track now. Now we need molar mass. Now molar mass of sodium carbonate. Looking at the periodic table, we are able to determine the atomic masses, and those atomic masses can then be used to determine the molar mass. If you are not confident about how to determine molar mass, there are separate videos on the channel which you can use to clear your doubts. So I get this as 106, and water is super easy. That is 1 times 2 plus 16 gives me 18. Of course, we cannot have a molar mass of the solution because solution is a mixture, it's not a compound. Got it? Okay, so we've got a lot of data in place. Now what do you have to do? Yes, very simple. Take it one by one and substitute the values and get your answer. And to get your answer, what do you have to do? You have to press the pause button in this video. Try the question yourself, and if you are able to understand this method, don't forget to put a smile in the comment section. It will make me very happy. Thank you. Okay, so the first thing that you had to do was mass percent, right? So that means the weight of the solute divided by the weight of solution. Remember, times 100. So from the table, now see how this table is so helpful. 24 divided by 640, both are in grams, times 100. Second one, you want to know the answer, you want to check your answer. Now I got an answer of 3.75%, right? Is it correct? Oh, very well done. Next step. Yeah, well done for me. My answer is correct. That's why I'm feeling happy. Okay. Next, molarity, capital M. That means the weight of the solute that I've got over here, which is 24 divided by the molar mass of the solute. So we'll have over here 24 divided by 106. And yes, of course, the formulas are in place. I have erased out the formula just to give me more space to write. Molarity is weight of the solute divided by the molar mass of the solute times the volume of solution in liters. Perfect, and we've got that in place. So we just substitute the value. What is the answer coming to? Can you tell me the answer? I got it as 0.566 molar. You could also leave it as 0.57 molar because that will bring us to two significant figures. That's usually expected in most of the examination systems, but you may also be asked to find your answer up to three significant figures, so you can leave it as 0.566. Okay. Next, of course, one more thing. Sometimes there are differences at the third decimal place. If you are doing the question manually, that means you are calculating it manually, or if you are using a calculator to solve it. I have solved part of the question manually and part with a calculator. So please make sure that you have that clarity in mind. Okay, molality again. So weight of the solute, that is 24 divided by the molar mass times the mass of the solvent in kg. So mass of the solvent 616. What am I going to do over here? I am going to convert it into kilograms by dividing by 1000, and we get a value of, give me the value. That's what I said, pen and paper chemistry. That's what the channel is about. Do the question yourself. Okay, did it? It's 0.368 molar. No. I'm writing it as the capital M. Is that right? No. What do I have to write it as? It is better, and to avoid confusion, we write it as molar. Molality symbol is also denoted by small m, but to avoid confusion, what we are going to do is we are going to write full MOLAL. So my solution is 0.368 molar, whereas molarity is 0.566 molar. Did you get all three correct? Very nice. Well done. Okay, would you like to extend your learning to solve the next question? The next question says, a 36% by weight of an aqueous solution of KOH is 7 molar, MOLAR. calculate the density and molality of the solution. Okay, so let's do our steps again. What do we have to find? We have to find molality, and for molality I need the weight of the solute, the molar mass, the weight of the solvent times 1000 in the numerator. That's the first thing. So I need certain data, and then of course for density of the solution I need the mass of the solution divided by the volume of the solution, right? So let's get started with the next step. What do? We tabulate. Now many of you would be thinking that drawing these lines, it's time consuming, and do we have that much time? See, if you draw these lines and you tabulate, there will be more clarity in your thought process, and the chances of your making an error will also be reduced. But there is no compulsion for you to do the question in this manner. You can always do it whatever way suits you. Okay, so I need the weight over here, I need the molar mass, right, and of course the volume. So again, going back to the question, it says 36% by weight. That means in a solution which is 100 grams, so that means my weight of the solution is 100 grams. There is only 36 grams of KOH in the solution. That means it becomes easy for me to find out the mass of the solvent, that is 100 take away 36, which gives me 64, right? Okay, next step is the given solution is 7m, that means 7 molar, whereas you have to find out molality. So let me put over here molarity, which has been given to me as for the solution is 7 molar, correct? Let me see where I can use it. Calculate the density. Now for finding out the density, I need the mass of the solution, which I have over here. I don't have the volume of the solution, but at the same time I do have mass of the solution and I have the mass. So let me try and calculate the mass of the solution, the volume of the solution. How can you do that? See, you have something given over here, that's the clue. And there are certain things which you can fill in this table. Molar mass, I will give you the atomic masses. Potassium, use the data as 39, oxygen is 16, hydrogen is 1. Don't forget that this is an aqueous solution, that means your solute is KOH and your solvent is H2O. So calculate the molar mass of KOH. How much do you get? So 39, 16 and 1, you get it as, does it come out to 56? And what about water? Yes, this is 18, right? So solution will have no molar mass because it's a mixture. Makes our things easy. Okay, so molarity, I am going to use something which is already given to me. The weight of the solute, molar mass of the solute divided by volume in liters, right? So, but volume in liters is not given to me. This is something I have to find out. Next step is I am simply going to substitute the values looking at my table 56, volume of the solution in liters. Please solve it, give me the answer. These questions have been taken from various reference books, but I've tried to modify the data so that you can do the calculation in an easier way without having the need for a calculator. So I get the value of volume as 0.09183 liters. and I can also write it in milliliters by multiplying it by 1000. 1 liter is 1000 ml, right? So I get it here as 91.83 milliliters. No, there's no compulsion that you have to convert it into milliliters. You can, you may not, but you will realize that when we are to calculate density, usually the density is in gram per milliliter. It's not in gram per liter. So it is better for me to write down the volume in milliliters and complete my table as well. So now density of the solution, you can find it easily, correct? So density is given by mass per unit volume. So mass of the solution divided by volume of solution. So you see, the tabulation of the data removes any confusion that you may have. So the mass of the solution that we've got is 100 grams and the volume of the solution that you've calculated just now is 91.83 milliliters. This gives us a value of 1.088 gram per milliliter. Good going so far, right? Now using the same fundamental, now can you calculate molality? That's the weight of the solute, 36. Molar mass of the solute, 56. Weight of the solution or the solvent? Yes, it's the weight of the solvent, which is 64. And why do we do 1000? Because we've got to take the weight in kilograms. So let me just calculate molality. So molality would be given by weight of the solute divided by the molar mass of the solute times the weight of the solvent in grams times 1000, and this gives us a value of 10 molal. Did you get it right? Very nice, well done. And it's okay if you didn't get it right. We are still on the second question. You are in the process of learning. If you did know, maybe you wouldn't be searching YouTube, right, for this kind of a content. Ready for the third question? Yes, you can see it on your screen. You can pause the question and solve it yourself. Try doing the tabular method. Trust me, it's very easy. It removes a lot of confusion. Did you try the question? Yes, I was waiting all the while. Just waiting to see that you do the question. Okay, now if you see over here, the question says that you need to find out molarity and you need to find out molality. That means I need a lot of things. I need the volume, I need the mass of the solvent. So as you can see, I already tabulated the data: solute, solvent, solution. I don't know, personally I found that this technique is helping me a lot in being confident about my answer. So if you see over here, it says concentrated aqueous nitric acid is 68% by weight, right? So 68% means how much solution have I got? I've got 100 grams. And how much of the solute is there in it? 68 gram. That means how much of the solvent is there in it? Simple. 100 take away 68. What do I get? Yes, I'm solving it like a student of grade 2, right? But it is good as long as it is helping me to get the correct answer, 32 grams. What else is given? It says if the density of this solution is 1.6. So I've got the density as 1.6 gram per milliliter. As I said, don't forget the units. And you can very clearly see where we are going. We've got the weight of the solution. We've got the density of the solution. Can you find out the volume of the solution here? Volume would be mass divided by the density. And by the way, there's nothing wrong with this method because I am showing all the steps of my working. What I'm going to do is I'm going to leave it as 1 by 16 liters. How did I get liters? Yes, because you had 100 grams and you are dividing it by 1.6 gram per milliliter, right? Per milliliter means milliliter goes into the numerator. Gram. The unit that you are getting over here is milliliter. In order to convert this milliliter into liters, what do I do is I divide it by 1000. So here zeros and I will get it as 1 by 16 liters. Yes. If you did not convert it to liters, very good, because I know for sure that you will be frustrated now with yourself, but you won't make the same mistake in the exam, and when you'll come out from the examination room, you'll be happy with your performance. It's okay to make mistakes because that is where we learn from. Okay, so let's get going and we will find molarity first, that is weight of the solute, which is 68 grams, divided by the molar mass, which is 63, times volume of the solution in liters. Now you understand why I converted it into liters in the first place. 1 by 16, so this will give me the value in molarity, that means moles per liter. What's the answer? What is the answer that you got? I got here 17.26 molar. I hope I got it right. Okay, and if I got it wrong, good, because I will also learn from my mistake. Yes. Okay, molality, weight of the solute again divided by the molar mass of the solute into the weight of solvent, which is yes, of course, the weight of the solvent is 32 grams. But what do we have to do? We have to convert this solvent weight into kilogram and get our answer, which is 33.73 mol. There could be slight variation between your answer and mine, maybe in the third, fourth decimal place. So it's okay for now because there's a difference how we are doing it and the precision to which we are finding the answers. As long as you're getting 17.2 or 17.3, if you've written your answer as 17.3 molar, even that is correct. Question number 4 on your screen. And I've tried to give you a practice of different calculations. So question is, calculate molality of the solution, molarity of the solution, mole fraction of each component in a solution. You have to calculate all three of them. For which solution? For a 10% weight by weight aqueous solution of glucose. Given density of the solution is 1.5 gram per milliliter. Now taken 1.5 for ease of calculation. Usually it's given like 1.7 or 1.685. I thought, why to torture the poor students? Let them go through some easy drills so that you can be happy with your learning. It is more important for you to enjoy your learning rather than just memorizing for the sake of examinations. If you enjoy, you will learn more. Okay, I have a few more questions lined up for you, but what I'll do is I'll carry it on in the next video. In the meantime, try these questions yourself. You can pause the video. Next one as well. Try it, and I will come up with some more questions so that you can gain confidence when doing numericals of any type, not just molarity, molality and mole fraction. Let's get connected in the next video. Till then, happy learning.